With this lecture starts a new module on sequences and series, and when we were looking at matrices, we were looking at linear equations, right? Like y equals 2x plus 1. And we kind of skipped over a lot of the different details related to that equation and, well, really function, because we had studied it already. We know it's a line, and it has a certain slope and intercept and domain and range. But now I'm curious, what if we look at a different domain? So I mean, our maximal domain is all real numbers from minus infinity to infinity. But now, what if we looked at a different domain that is only the natural numbers? So if we imagine our normal or our graph previously, right, we had an x-intercept of 1 for the equation y equals 2x plus 1, and then we went up 2 over 1, up 2 over 1, and we got this nice line, something like that. Okay, but now what if we looked at only the natural numbers, so when x is 1, 2, 3, 4, etc. And so that would just be, in red here, it would just be these dots that represent, oh, I missed the mark there. And actually not even there because I can't have negative numbers. Um, so and actually I don't even have 0, right? So it's just when n is 1, I'd have this value. When n is 2, I'd have this. When n is 3 is that. And for 4, I'd have this. And 5, etc., etc. So my domain, because of my different domain, I have a subset of the outputs. Okay, I don't have all the values in between, and in particular, I don't have anything 0 and under. Okay, so when we look at that series of red dots, I shouldn't say series, it's actually a sequence of red dots, forms what we call a sequence. Okay, because of that shifting in domain. So when we look at any set of real or any function, and we just change the domain to be the set of natural numbers, also known as positive integers, that just forms an infinite sequence. And similarly, if we're looking at just the first, however many, the first n of them, that becomes a finite sequence. Okay, when we talk about sequences, to differentiate those from functions, we introduce some different notation. So we use just a sub n, and sometimes, particularly with infinite sequences, we use it in curly braces. Okay, generally though, we're going to be focusing on this notation. Okay, but the other one will pop up. Okay, when we use this notation, we generally refer to that as the nth term, and some books also call it the general term. Okay, and that just means that it's going to be corresponding to a positive integer n, or our natural number n. Okay, so just to get some practice kind of using this language, we have a couple examples below. Okay, and I just want to write out the first 4 terms. So it's saying the general term is given by this, and if I'm looking specifically at a sub 1, for instance, that just means that n is 1. Okay, so let's put in 1. 3 times 1 squared plus 1 plus 1, or 5. A2 is going to be 3 times 2 squared plus 2 plus 1. Okay, and evaluating, we get 4 times 3 is 12, 14, 15. A3, okay, we would get 3 squared is 9 times 3 is 27, plus 3 plus 1 is 31. And then A4 is going to be 4 squared. Okay, I'll write out 4 squared plus 4 plus 1. Okay, so 16, 48, 52, 53. Okay. So there we go. With b sub n now, this one has this n minus 1 to the n times n squared. So b1 would just be negative 1 to the 1 times 1 squared, or negative 1. b2 would be negative 1 squared times 2 squared. Okay, so that would just be a positive 1 by squaring, and then I just get 4. Okay, next one I'm going to challenge you to show is, so B3 is going to be -9, and then B4 is going to be 16. Okay, so I found the first 4 terms in each of these sequences. So if I were to, see these sequences in nature or just in a book, I would see them expressed as 5, 15, 31, 53, and so on and so forth. Similarly, with the sequence Bn, it would just be -1, 4, -9, 16, and so on. Okay. One interesting thing about the sequence Bn is this factor of n minus, or -1 to the n, and that just means that the sequence is going to alternate. And surely enough, it did alternate as we look between successive terms. It's changed from positive to negative or vice versa. Okay. Generally, we're going to see that pop up in a couple different ways. We could either see the factor of n minus, or -1 to the n, or -1 to the n minus 1. And when we see this, if we can just imagine like C1, C2, C3, this one, all the odds are going to be negative, 1 and -1. Okay, so this just means that the odds are negative. Okay, and this one, similarly, the evens are going to be negative. So for example, we have C1, or I should say D1, D2, D3, D4. This is going to be -1 squared, which is just 1, and then -1, +1, and -1. Okay, so just be aware of those in the future. And so now we have a little bit of an idea with sequences and what they are, and how they're really just pieces of a function. But this, of course, isn't the whole story, so we'll get some more information in the next video.